Hello, now we are going to have a look at one of the types of proof by induction questions. So proof by induction comes up on paper 1, and we are looking at 2019 paper 1 question 2 part B, I think. And we are looking at when if f of x is equal to 3 to the power of x, g of x is equal to 4x plus 1, prove that f of n is greater than or equal to g of n for all n greater than or equal to 2, where n is a natural number. Now, the real key important thing for a proof by induction question is the first 50% of the marks require you to remember 2 steps in any proof by induction question. So that's what I want to really highlight here. The final part of the maths is important for getting all of the marks for the question, but these are incredibly easy to pick up about 50% of the marks in. So that's really what I want you to take away from this. Don't shy away from proof by induction because they can be very complicated to finish. They are always incredibly easy to get the first half of the marks for. So make sure that you never leave a proof by induction question undone. Always look for doing at least the first 2 steps in any thing that says prove by induction. The first step is always going to be to take your, I've actually gotten ahead of myself here, take your statement f of n greater than g of n for n greater than or equal to 2. Always show that this relationship holds, for n plus 1 for the smallest value of n that you can be dealing with. So in this case, usually in a series question or something like that, you'll be dealing with the smallest value of n in your relationship would be n is equal to 1. So the most common type of proof by induction question is where you have your series and you're dealing with n equals 1 is the smallest value. Here it explicitly tells you the smallest value is going to be n equals 2 because we're looking at a situation where n is greater than or equal to 2. So our smallest value we can sub in to double check that this works is going to be n equals 2. So we do that one, n equals 2. We have 3 to the power of 2 and 4 and 2 plus 1. Just work that out. Plus 1. 9 is greater than or equal to 9. That is true. So it is true for the smallest value of n that we can be dealing with. Usually, again, that's going to be n equals 1. In this case, it explicitly tells you it's going to be n equals 2. That's your first step. You can always do that, and that will, in this question, give you 4 out of 15 marks. So we're definitely going to do that part of the question. You can always sub in your smallest value and just show that it's true for a particular value. That gives you 4 out of 15 marks. It takes basically no time at all in terms of an exam question. Part 2, always, is assume this is true. Assume true for n equals k. K is just some particular value. K could be 3, k could be 100. We don't know. K is just some particular value. And we're going to say that we're going to assume that this is true. Now, in the marking scheme for this year, and it's very normal, it's actually slightly lower than you'd sometimes get, for getting to this point where you have written that assume n equals k works and that you have worked out n equals 2, you get 7 out of 15 marks. We're about halfway there. We've done basically no maths. You just have to remember, define n, or sub in n, the smallest value of n you can, in this case n equals 2, and then say I assume that n equals k is true, and you write down the equality or inequality with n substituted in as k. That will usually give you about 50% of the marks for the question, and it takes no time at all, and you can always do it. Now the next part of the question varies quite a bit and can get quite finicky, but if you make any kind of attempt at the next section, you can often get up to 3/4 of the marks. So our next step is, if we do this assumption that we did in part 2, that n equals k is true, then we must show n equals k plus 1 is true. You can write down true. My ability to write is quite poor, so I use a tick for true. So that is what we want to do. And write in these steps. Do it as part 1, part 2, part 3, and say what it is you're doing. Particularly when you're practicing questions, it will stick the steps in your mind, so you're getting your blocks of marks when you get to the exam. So we have, what does n equal k look like? Well, we know that it looks like 3k is greater than or equal to 4k plus 1. It's often helpful to restate n equals k because you're going to use it almost always as a substitution or relate what you're about to do back to this relationship. So it's very good to rewrite it here so you can immediately look at it when you're doing question. And as always, I've broken up my answer page into at least 3 columns so that I don't run out of space. Now I'm going to write down what n equals k plus 1 is going to look like. You just sub in, you can put it in brackets if you like, k plus 1 anywhere there would have been an n in my original relationship. That can look quite messy in some questions. It's not too bad in this one. So anywhere you would have had a k in the line above, you'd put a k plus 1. Work that out. This one might not be terribly obvious to people. If you are adding the powers, that means you are multiplying the bases. So this is 3 to the power of k multiplied by 3 to the power of 1. So rules of powers. If you think about it the other way, we have the same base here. If we multiply the same base together, we would add the powers. So we have our powers added together up in the top line. This is just multiplying out a bracket. So 4k plus 4 plus 1. So 3 to the k. And you have 4k plus 5. Now, you'll likely have gotten 3/4 of the marks for getting to this point, but the thing that would guarantee you your next block of marks is to recognize that if you've isolated 3 to the power of k, you would be able to effectively do a substitution. It's not quite a substitution, but if we know that 3 to the power of k is greater than our 4k plus 1, we've assumed that fact, then we could do a substitution in here, and if we can show that this this left-hand side is greater than the right-hand side, then we will definitely have shown that this is greater than this. I'll show you what I mean now. So we are going to do effectively a substitution. We're going to sub this in. We know that that is greater than or equal to 4k plus 1. So we can effectively substitute this in here, and if this new left-hand side, 3 times 4k plus 1, is definitely greater than 4k plus 5. If this side here is definitely greater than the right-hand side, then the original left-hand side must be even greater than our right-hand side, because we know that, 4k. We know that 4k plus 1 is less than 3 to the power of k. So if we can show that this version of the left-hand side is greater than this version of this right-hand side, then definitively we know that our original left-hand side is also greater than or equal to the right-hand side. Now, that's the phrasing you would use for this style of question. Usually in a proof by induction question, you will be getting you would be doing a slightly different type of rearranging. So this part is a little bit unique to this style of proof by induction. But again, we've already gotten at least 50% of the marks for the question for doing very little work. So let's work this out. We get 12k plus 1, sorry, 12k plus 3 on 4k plus 5. Now, at this point, for some reason, you are entitled to say this is definitely true when k is greater than or equal to 2. I have never been able to keep track of when it is you're allowed to make that assumption. I will show you what I always do in this question, and that's effectively to solve this inequality. Show when is this relationship true for k. So I rearrange this to get k is greater than something. So I get 8k is greater than or equal to 2. Divide both sides by 8. And we see that this relationship that we've worked out here is true when k is greater than or equal to 1/4. Now, if it's true when k is greater than or equal to 1/4, it is definitely true when k is a much bigger number, when k is greater than or equal to 2, which is actually what we are interested in. The original relationship kicks in when our k value would be 2 or greater. So if our relationship is true when k is greater than or equal to 1/4, then it's definitely true when k is greater than or equal to 2. So therefore, if true for k greater than or equal to 1/4, then true for k greater than or equal to 2. As I say, this is not the way you will see it in most of the books. It's just the way that I find it a much easier explanation to understand, because this is still, where are we? This is still a fairly complicated inequality to just state this is true for k greater than or equal to 2. So technically at this line here, you're entitled to just state k, this is true when k is greater than or equal to 2, but to me that doesn't make a great deal of sense. So I always go down and actually solve the inequality and then say if it's true for this smaller value, it must be true for the range that we're interested in. Now, final step for the final block of marks, to go from 3/4 marks up to full marks, is to do a final statement. And there's a bit of writing in this, so I'm just going to pause and come back when it's done. So this is a version of what you can write for your final statement. And again, this is your final block of marks. Down to here gives you 3/4 of the marks usually. This is your final block of marks. So definitely include this if you've managed to get something reasonable here. So what I'm stating is I've shown that if something is true for a particular value of n, it must also be true for the next value of n. The next consecutive value of n would be another way of putting this in English. If it's true for a particular value of n, it's true for the next value of n, or next consecutive value. And I showed that it was true for the smallest value of n I was interested in, n equals 2. Therefore, it must also be true for the next value of n. The next consecutive value of n would be 3. And if it's true for 3, therefore it must also be true for the next consecutive value of n, n equals 4, and so on forever. Therefore, it's true for all. Remember, our upside down capital A means for all, but you can just write for all in your English. Therefore, it's true for all values of n greater than or equal to 2. But again, what I really want you to take away from this, because this bit can get finicky and it changes quite a lot from style, from different types of induction questions. This first block of the 50% of the marks, everyone should do every time. It is incredibly easy marks if it comes up on the exam. Here can get a little bit messy and specific to different styles, but this is always the same and incredibly easy, very fast marks. So that is how you do this style of proof by induction.